welcome to another interesting day. Welcome again. It's another interesting day. Learning OpenCV with Python. So we're going through the basics for the past few days. We looked at the OpenCV, the functionality it has, and we've carried out a few projects, 2 or 3 projects with exploring the functionalities of OpenCV. So today we'll continue with another very interesting project, one that is quite practical, especially in the security industry. So we will be looking at a face blurring application with OpenCV. It's a very easy project, but very useful too. It uses the core functionalities of OpenCV and also uses other libraries. That's to show that um, OpenCV is not very exclusive, that other libraries can be used with OpenCV. All right, so how are we going to go about doing this? So the procedure we'll carry out, we will follow, will be very easy. First of all, of course, we are going to get the pictures using pictures, the frames, the video frames, streaming frames, video frames using conventional OpenCV. Then we've done that severally in other projects. Then we'll check for each frame, look out for, remember the last project we did, we checking for barcode. So we looked out for barcode. So in this case, we'll be looking out for faces. So we're going to use a third party model for doing that. And once we look at the faces, we will we'll isolate the shape of the face, right? We'll get a rectangle that picks the bounds of the face, then we'll use a Gaussian blur to blur that rectangle, just like this. This just covers the face, then we now use the rectangle to blur the face. Then I think that's that. And just it's out there for you to view. So let's just get into Python code and see how we can do it. It's going to be a very short video. All right, so first of all, let me create a folder. Yeah, okay, and call it face blurring. Then once I've done that, let me just create a file. Just call it main.py. All right, beautiful. So just like I said, this is the procedure. First, we'll get camera, then isolate face, blur face, output, and end. Beautiful. So let's start. So of course, first you import CV2, which is basics. Then of course we do the basics. We cap is equal to CV2 dot video capture 0, right? Then if cap right? So if this works, of course you know how this works. This is if your webcam opens, right? If your webcam opens, if it does not open, it's just a way of catching the error. So I simply print error unable to access webcam, right? So that's just housekeeping, right? And then of course, how is it? Else, do I even need to put the else? It will exist, so I can just continue. So what happens now is I'm going to go through the conventional loop. I'm going to go through the entire. The while tree is, of course, so that it keeps going on, keeps running. So I can say this will return true or false, whether it can the camera is returning anything true or false. Frame will be equal to cap dot read. Of course, remember we are just interested in the frames. So if not return, that is if return gives none. Again, this is just housekeeping once more. Sometimes your head can just be fuzzy. Print error. Alright, so the other one we could not access webcam. Here we cannot read from webcam. So this is just housekeeping, just a basic housekeeping. Alright, so let's now do the major thing. What if that is not the case? What do we do? Let us remember that it's good to know that OpenCV text image as BGR, but sometimes we may need to process our image as RGB, right? Or as gray in gray form, right? So the first thing I'll do, because of the speed, when you are processing in gray form, is actually faster. Because of the speed, I think the best thing will be to convert our image to gray form. Then maybe when we want to display, we take it back to colored, right? Because gray form is faster to process. So let's just call our image gray, which will be equal to CV2 dot CV2 dot CVT color. Alright, so to take first of all to take the frame, then CV2 dot color BGR to gray, right? So it's now in gray form. You can just call it IMG. Right, let me just call it IMG. So if that is the case, now I want to detect the face from this image. So I'm going to use a face detector. Now, what face detector will I use? There's one that is very popular. That's the cascade detector, right? That's the cascade detector. I'm going to show you now. It's very popular. The has cascade detector. So this is it. Um, right. The has his cascade detector classifiers is a group of classifiers and effective object detection method um, that proposed a long time ago. Uses machine learning approach, right, to detect objects in other images. This is what we are looking for, objects in other images. So for example, it can detect the eye, can detect the eye in the face, can detect the nose in the face, can detect the face in the whole pic in other in the from the part of the body, other parts of the body. You can do a lot of you can detect the leg, right? Detect different part of the body. So there are there are so many of them. So for example, look at this case here. You could detect here, you could detect here. Another very good example is this. You could see that you could detect the face, which is the big purple circle there, and you could detect the eye, which is the blue circle here. All right, so there are so many of them. There are so many of them. We have some here. So let me to come up. Right, you can have here that detects the eye. Here detects eyeglasses. Right? So there are so many of them. So just go to this. If you can go to this GitHub, Hey Cascade GitHub channel, GitHub page, we see several of the models that are ready to use. There's no point here. Can detect the smile, the upper body, so this and the lower body, the left eye, the full body. So there's no point in training another model when we have something that exists already. Rather use our time to design something else. All right. So that being said, let's see how we can use it. So for this project, I'll be using the face. I'll be using the frontal face default. See? So I can simply download it from here. Right? So I can simply download. Oh God, can simply download it here, and then I'll import it, and that is exactly what I'm going to do. I'll download it now. I'm going to import it. So I've downloaded that CV2 dot cascade classifier. Then which of the cascade classifier am I using? So this is the one I'm using. So let me just copy path, which is basically the name. We are here, so there's no I don't need this. So the haze cascade frontal default is the one I'll be using. So that being said, we've gotten our face detector. The next thing will be for us to detect the face from here. We use it to detect the face. So you have got faces. In case there is more than one face, it's face detector. Detect multi-scale. Right. So now this face, the cascade detector takes the detect multi-scale takes some features. One of these, of course, will be our image. Then it will also take the scale factor. What does the scale factor do? It it will help reduce the image, right? It sets the reduction factor as you pass it through the model. So I'm going to set it at 1.1. All right. Then we also have the minimum neighbors, which tells us the minimum number of rectangle, the minimum number of rectangles we need to maintain a detection. All right, so I'm going to send it at, I'll set it at 5. I think that's that. So that being said, all right. So next, I'm going to look through. It's going to capture a lot of faces. So I'm give it to me as coordinates on the picture. So I'm going to get the coordinates of that, um, the coordinate of those pictures. Right. I'm going to get the coordinate. Then this is what I'm going to do. For example, this is now my face, right? Right. So it is a face. What I'll do is I'll come here. I'll cut this part out, right? Cut it out. Then I'll now blur this box. I'll blur this box. When I now blur this box, I now take it back and replace exactly where I cut it out. You can see it here. So this is now a blurred version of the face I had cut out from here. All right. So that is exactly what we are going to do. We're going to do it with code right now. So how do you do that? Oh God. First of all, I'm going to loop through. Right. So for x, y, the width and the height. Once I have this, of course, I have a rectangle in frames. This is how the coordinates will be given to you. If you print this out, you're going to see it. If you print faces out, you see it. To give the x and the y coordinate, which will be your top left. Then with the width and height, you can get other parts of. You can construct your rectangle. So we're going to extract the face region. Remember I said you're going to go and cut that rectangle out, cut the rectangle out. So I'll just call it face region, right? Face region is frames. Then we have this as a y. All right. So that being said, now that has been cut out, what do we do with it? We blur it. We blur this face region. So we just call it blurred. Now, there are several methods of blurring faces, blurring pictures with OpenCV. We have the Gaussian blur. We have several types of blurs which um, you can look up. But for this, so I will not really waste time. You can search Gaussian blur on the OpenCV their page. You see a lot of them, but the one we're going to use here, right, will be the Gaussian blur. The Gaussian blur. So what really makes a Gaussian blur better than other ones? Gaussian blur uses a bell curve, the Gaussian function, um, to determine the weights of different adjacent pixels, right? It does this such that unlike one box, it does an average blur, right? Um, Giving equal weight to all the pixels, all the neighboring pixels, rather than really promoting one, right? Now, the Gaussian blur looks more like something is blocking the camera, like maybe it's cloudy, rather than a blocky. It's completely blocked. Rather, it will look like it's cloudy. You see that there's something behind it, but you cannot see what is behind it. So that's what makes Gaussian blur very standard, and it's very very popular, especially when it comes to blurring images. Right? It gives this feel of, oh, I know that something is still going on, but I don't know what is I don't know what is going on. So we have this as Gaussian blur. This is how you do Gaussian blurring in OpenCV. Just call Gaussian blur. right? So what does it take? It takes the what are you blurring? So we are going to give it a face region. Remember, this is just the face now. On blot, just the part you cropped out, right? Then the size, right? The this are some of the parameters that you need to set for the blurring, so you can play with this. I had to play with this a bit. Then you also take Sigmax, which is 20. So these are the parameters for Gaussian blur. All right. So that being said, we can now, what we'll now do is I will now take it back to the frame, right, to our picture, and then we'll now replace it. So our face, I think I'll just copy this. Will now be blurred. So it is why this is going to fit seamlessly into the old picture. So it's rather we just cut it and then replaced it, right? It's not as if we blurred on the pictures. All right, so to give you the impression that yes, we blurred on the pictures. All right, so that's, I think that's everything. So I can just show it. All right, I can just show it. Let's just call it real-time face blurring. We've been playing with if show, so you should know how it works. Then of course the frame. All right, so but remember that most times when we are using webcam, we want to look for a way to end it if we want to end it. So if cv2 dot wait key, right? I guess you know what this does. It keeps checking after every some milliseconds, so 1 millisecond, so it will be rather fast, right? If so if you press Q on your keyboard, it should end it. It should just break out, right? And then that will be the end of it. Then once it breaks out, the other housekeeping things we've been doing, right? Cap.release. Right, so you should know this already, and of course the destroy all windows. Alright, so I think that's all. I hope you understand every single part of this algorithm. First of all, this is the face digital model we are using. This was used to get the video, right? This is just housekeeping for errors, right? We have two errors here. One, when you cannot access the webcam, and two, when you cannot read anything from the webcam. So okay, then we get an image, right? Then we change the image to grayscale, detect different part of the image, detect faces from the image using the model we got. It's strange that I have some. Why is it complaining? Okay, I think there's a comment. All right, then it looks through all the detected faces, right, that it must have recognized from the image. Then it cuts out each the face, the part of the face that's from the image. Then it replaces it with a blur, and then you show it. That's all. So let me just run this and then let's see if it works. All right, so I think this is bad spelling here. Release. Yeah. I continue different from the webcam. Yes. That's because I'm using it for the video. So let me just remove the my face. All right. So yes, so this is what we're looking for. You can see it has recognized my face and blurred it, probably because of my light. That's why sometimes it goes off and on. But that's it, and that's what our code does what you wanted it to do. So it's fine. So please look at that, try it on your own. Then if you have any question, don't forget to drop it on the comments. And if you have any suggestions too, don't forget to drop it on the comments. Remember, I also learn. I'm also learning. We all learn every day. I like learning new things, like listening to other people's opinions. But so don't forget to like and share too. Thank you. So we'll see you in the next video where we'll pick another very interesting project.